Okay, so chapter 8, question 6, elastic collision. A block of mass m equals 3.6 kg moving on a frictionless surface with a speed v initial equals 9.3 meters per second makes a sudden perfectly elastic collision with a stationary block of mass m, as shown in the figure. Just after the collision, the 3.6 kg block recoils with a speed of vf 2.7 meters per second. What is the speed v of the other block? So in the case of the perfectly elastic collision, the velocity of the collision after the collision for the first body is v equals m1 minus m2 over m1 plus m2 ui plus 2m2 over m1 plus m2 v2. And for the second body, it's going to be v2 equals 2m1 v1 over m1 plus m2 plus m2 minus m1 plus m2 v2. Then that gets simplified into v1 equals m1 minus m2 over m1 plus m2 u1 arrow to the right 2.7 equals 3.6 minus m2 over 3.6 plus m2. We then have negative 9.72 minus 2.7 m2 equals 33.48 minus 9.3 meters squared equals m2 equals 6.546 kg. Then for v2 we have 2x or 2 times 3.6 times 9.3 equals 6.6 meters squared. It was 2 times 3.6 times 9.3 over 10.15 equals 6.6. So then for the perfect elastic collision, v2 minus v1 equals u1 minus u2, v2 equals u1 plus v1, which ultimately, when we plug in our numbers, is 9.3 minus 2.7, which gives us 6.6 meters per second.